Okay, it is time to talk about titrations. We will look at a lot of titrations throughout this semester. I mean, more so in the lab class than we will in here. But titrations are amazing, accurate, frustrating, and super important. So, we're going to start with just an intro to titrations, and we are also going to talk about indicators in this intro. So, a pH indicator is a substance that changes color as the pH of the solution that it's in changes. The identity of the molecule determines its color and its pH range. Now, we use pH indicators to, I guess, time out our titrations to figure out where our titrations end because it's a really nice visual cue that can work incredibly well. You can also use something like a pH meter and make a graph and graphically determine when your titration is over. But indicators are still pretty universally used because it's really nice to have that visual cue. So, an example of an indicator is phenol red. This has a pKa of 7.6. So, pKa, negative log of the Ka, this is a weak acid. So a pKa of 7.6, what this means is that at a pH of less than 6.6, what we have present in solution is the protonated version, so the full molecule non-ionized version of whatever the indicator molecule is. And in the case of phenol red, when it is in this form, the solution that it's in will be clear to maybe a little bit light yellow. When you get to 7.6, which is about the pKa, you have a persistent yellow color. And then when you get to 8.6 and greater, what you have is the ionized version, so just the split up version, just the conjugate base and an H plus. And above that pH, the solution is red. So the range that we're looking at here is plus or minus 1 around the pKa, where the color of the indicator is changing. And so it's over this range that, right, like you can get one molecule that would be yellow or colorless versus red, um, but one molecule in an entire sample, that one isn't going to do it. This range represents when you have enough to distinctly show that color. And just to make sure we're clarified, pH less than 6.6, that should say solution is colorless to light yellow because clear and colorless are not the same thing. So the way that we use indicators, you'll just use one drop and it will be used to show the pH change in a titration. So what the heck is a titration? If you have not seen one of these set up before, it is an analytical method for determining the concentration of a solute, and the way that you do so is by reacting it with a standard solution, where a standard solution is something of a known concentration. Usually it means it's if something has been standardized, usually means we've titrated it at least in triplicate and calculated some statistics for it to ensure that it falls within the correct ranges. What the setup looks like is that you'll have this piece of glassware called a burette. So that's that long, skinny thing that has a little knob and nozzle at the bottom. The titrant is what goes into your burette. Usually, you can also do things called back titrations, but for how we're going to set this up from the beginning, the thing that you know will be in the burette. And then in usually an Erlenmeyer flask, you'll have your analyte. Usually this is the unknown, and right, known, unknown, done. Like now we can just figure out what we need to do to mix these together and find out information about the unknown. So a burette measures volume. So what you would do is add titrant to the analyte flask until you have some signal that you've done everything you need to do. And once you find out how much titrant you need, you can use the concentration of the titrant, so concentration of the stuff in the burette. When you know the volume, well, you have concentration and volume. You can find the moles of titrant that were added. The moles of titrant will tell you how many moles of analyte were in your flask. And if you knew a volume, you could do concentration of the analyte. When you have concentration of the analyte, you can find the pH, you could find the Ka, you could find the molar mass even. We can connect this to a ton of different information. Now, this data will very often be plotted on a titration curve. It can kind of help you visualize what's happening in the solution, and it will also give us data. It'll give us features of the analyte. You can graphically determine things like Ka. I mean, you determine it from pKa, but there's nothing wrong with that. It still connects. So we will look at titration curves. A titration curve, it's a plot of pH, and the pH specifically is in the analyte flask. So we're measuring the pH in the analyte flask, and then the x-axis is the volume of titrant added. So this is throughout the titration, and it starts at 0 because at the very beginning, it's just the analyte, so you have not added any titrant. Okay, so volume of titrant added as we go across. So the curve that we're going to look at, right, I've got my pH range on here, I've got my volume of titrant added. If I had a weak acid or a strong acid, what do I have here? Yeah, a strong acid in my analyte flask, 0 titrant added, I would expect to start at an acidic pH. And I do, and that's what you should see. Then as I add base, the acid and base will react with each other, so my pH will go up. Eventually, it will hit a point where it jumps drastically. So you will have a vertical or near vertical point in your graph or in the graph that you're looking at. And then as we get to the point where it's just excess base that's in the analyte flask, right, my pH in that solution is going to be basic. In the middle, so in the very middle of this plot, that will be the end point of the titration. It will be the equivalence point. Well, it will definitely be the equivalence point. So when you've perfectly reacted whatever was in the analyte flask. It will also hopefully be your end point, which is the end part, the point at which we are stopping based on the indicator. And in this case, what I've got it marked as is about a pH of 7 at the equivalence point. And that pH at the equivalence point will also mean something and will also tell you information about what you're analyzing. And we will look at that in a later video.